How do F1 teams prevent flow separation? Imagine driving a race car at over 200 miles per hour. The way the air flows over the car can make or break its speed and grip. Now, how do teams keep that airflow smooth and attached to the car's surface? That's what we're about to find out. One of the main tricks is using vortex generators. These are tiny devices placed on wings or the body of the car. They create small swirling air currents called vortices. These vortices energize the thin layer of air right next to the surface, called the boundary layer. When the boundary layer has more energy, it sticks to the surface longer, preventing it from breaking away or separating. Teams usually put vortex generators just before the spots where airflow might separate, often about 20 times the height of the boundary layer away from the surface. They also help guide airflow to produce more downforce, which keeps the car glued to the track. Another method involves blowing and suction techniques. Blowing pushes high-energy air into the boundary layer, while suction pulls away the tired, slow-moving air. These techniques are complex and requiring extra equipment, but they can be very effective. For example, some teams use duct systems like the McLaren F duct or Red Bull's S duct to control airflow over wings and the chassis. These systems help keep the airflow attached and reduce turbulence that causes drag. Teams also make small changes to the shape of surfaces. They add tiny roughness elements or shape edges to create wavy lines instead of straight ones. These passive modifications weaken vortex shedding and help keep the airflow attached. They are designed within strict rules to improve airflow without breaking regulations. The design of the floor and diffuser is also key. The floor of the car is shaped to accelerate airflow underneath, creating a low-pressure area that pulls the car down. The diffuser at the back helps expand and slow the airflow, boosting downforce. Recent regulations include Venturi tunnels, which are three-dimensional channels that speed up airflow even more, making the flow more stable and attached. Finally, controlling turbulence around the car's bodywork is vital. By generating controlled vortices, teams can help the airflow stay glued to the surfaces. This reduces turbulent wake regions behind the car, which cuts down drag and improves overall performance. In essence, preventing flow separation in Formula One is a mix of clever active devices like vortex generators and duct systems, smart passive shape modifications, and advanced floor and diffuser designs. All these techniques work together to keep the airflow smooth and attached, helping the car go faster and stay more stable on the track. Teams constantly refine these methods using computer simulations and wind tunnel testing to stay ahead in the race for aerodynamic perfection.